Hey everyone, it's Tony with Hidden Light Photography, and today we're going to be talking about how to choose a telescope and how to match a camera to that telescope. There's a couple of things you need to consider when choosing a telescope. One is going to be, do you want to do planetary or do you want to do deep sky like galaxies and nebula? If you choose to do planetary, you're going to want a Schmidt-Cassegrain, as that offers a lot of focal length with aperture, which is what you need to do planetary. The large aperture allows you to gather more light, which means more detail, and the focal length allows you to have a lot of zoom, which is a necessity when doing planetary. If you want to do deep sky, then you're looking more at a refractor or a Newtonian. A refractor uses lenses, Newtonian uses mirrors. Now, the other thing to consider is budget. Budget is going to determine what you get. Now, there's upsides and downsides to everything. Refractors, amazing instruments. They are lightweight, which means you don't need a mount that has a high payload capacity. On the other side of things, they get expensive very quick. Refractors need different lenses to correct, such as chromatic aberrations and things like that, and it adds up. On the flip side, Newtonians, they are low price. You can get focal length and aperture with them, but they get heavy, which means you need a mount that can handle a big payload capacity. Now, when you're looking at telescopes, now you need to decide, how much aperture do you want? The more aperture, the more detail, the more light you can gather. And then the other thing to consider is going to be focal length. Focal length is going to determine zoom and your field of view. Now, when you're looking at planetary or Schmidt-Cassegrain, you'll see a very high f-stop number or focal ratio number, somewhere in the range of f10, f15, somewhere in that range. What that number means is how fast does that telescope gather light. The higher the f number, the slower it is at gathering light. When you're doing deep sky, you're going to use a lower focal ratio, f4, f5, f6, somewhere in that range. Now, if you're just starting off, I recommend staying somewhere in the f5 to f6 range, especially if you're using a Newtonian. Now, Newtonians, I didn't really get into the cons on those, except for they get heavy, which means you need a mount with a higher payload capacity, but they also require periodic collimation. And I usually will check my collimation after 2 or 3 nights of use. And my telescopes, both of them so far, I've gone many sessions and have not needed to collimate them. Right out of the box I did, though. And all collimation is aligning the primary mirror with the secondary mirror. Very easy to do. It can be very nerve-wracking in the beginning. I was extremely nervous on my first time of collimating, but it's not bad. Just like the first time you dove off of the high dive. You get really nervous, you finally do it, and it's not bad at all. I prefer Newtonians. You get a lot of bang for the buck. They're very powerful instruments, but that comes into why I recommend an f5 or an f6 as a beginner, because the faster the telescope is, the harder it is to collimate. My Celestron Omni XLT is an f5. It's easy to collimate. However, my Skywatcher behind me is an f4, and that one, not hard. I just chased my tail a lot, but once you get the hang of it, it's super easy to do. This is where budget comes in, is if you're going with an 8-inch telescope, obviously it's going to be a little bit more. They get heavier. which means you need a better mount and things like that. So set a budget because you're going to need other things too, your camera and, autofocuser, which I highly recommend, and different things like that. You can always choose your accessories, but remember the main things that you're going to need are the OTA, the mount, the camera, and a laptop. That is your basic things that you need. And if you really want to get into things, you're going to need to use calibration frames. So a good flat panel is going to be a necessity as well. But I use highpointscientific.com. That's where I've got everything from. And browse on there, look at things, see if they fit in your budget. Now I'm going to show you exactly what your telescope is capable of as far as field of view with a camera, and also how to match it. So I'm going to bring you over to my screen, and then we're going to go through that. Now, when choosing a telescope and a camera to match it, the first thing you want to do is go to your web browser and type in google.com. From there, you want to type in astronomy tools. And you want to go here, astronomy.tools. You can do this on your phone, and I think that it has the 3 horizontal lines in the top right corner, but that'll bring up this menu right here. The first thing we're going to do is go to field of view and imaging mode. We'll choose M16 Eagle Nebula just for the sake of showing you field of view. And this is where you would put in the telescope that you're looking at. For this example, I'm going to use my Skywatcher, and you'll see it populates the focal length and the aperture. And then I'm going to put in my ASI 2600, and we're going to add that. And you can see this red box here is the field of view with that particular telescope and camera. Now, if you look at the 6248 by 4176 pixels for the 2600, and then we'll compare that with my other camera, the 533, and it just went to 3008 by 3008. And now you can see the yellow box is the 533, the red box is the 2600, and you can see the different fields of view. The same telescope, different camera. So that's one way to see your potential with a scope and a camera. And now, just for the sake of showing, let's get rid of the 533. And we're going to go back to the 2600. So now we have the ASI 2600 with the Skywatcher 8-inch. Let's go to my Celestron, and it's a Celestron Omni XLT, 150 Newtonian. So we still have the 2600 with the Celestron, but now our focal length changed. And you can see the shorter the focal length, the bigger the field. Here's the Celestron with the 2600, green, and the Skywatcher with the 2600, red. So there's a different field of view. And I was saying earlier about Schmidt-Cassegrains for planetary. Let's leave the camera the same, and let's go to the C11. The C11 Schmidt-Cassegrain telescope. And Schmidt-Cassegrains, I was also mentioning, you get aperture. This is a bigger aperture with a lot of focal length. Same camera. Let's add that. And you can see how this really zooms in. And that's how, now you can see why I said this is what a good telescope is for planetary. You get a lot of zoom with that. Okay. Now let's go to calculators, CCD suitability. And again, for example's sake, I'm going to choose my Skywatcher. I'm going to choose my 2600 camera. And here you go. Now, one thing you're going to need to do here is look up your local seeing conditions. I know that I'm in OK seeing, and this is full width half max. So make sure you look up your local seeing conditions. And if you can look it up in averages of full width half max, that's going to be the best way to do it so you can compare. Let's drop this down to poor. And you can see that this setup with the 2600 and Skywatcher goes to slight oversampling. On the flip side, if I bump this up from okay to good, I'm still in the green. And then if I go to exceptional, now I'm undersampling. If I had to choose, I would choose oversampling. Slight oversampling is okay. It's a lot easier to work out than undersampling, even if undersampling is slight. But this is going to be very personal to you. This is going to be the telescope you're looking at, the camera you're looking at, and you want to make sure it stays in the green. You always want it to stay in the green. But if you had to choose, I would go oversampling rather than undersampling. And one thing to pay attention to is this number right here. This is your pixel size, okay? Now I'm going to show you what happens if I take my 2600. You saw that between the 2600 and the 533, there was a difference in the field. So here's our resolution, 0.97. Let's go to the 533. And it doesn't change. And that's because the pixel size is the same as the 2600. Okay? What this means is our resolution is 0.97 arc second per pixel. And we'll get into that later, but I'll give you a quick example of what this means. Let's take the moon and put the moon on 1 pixel. How much resolution are you going to have? You're going to have a bright dot, just a bright dot. Now, if you take 1,000,000 pixels and put those across the moon, you're going to have a lot more resolution. And that's what this is, okay? Now let's take my third camera. I do have an ASI 585 MC, which is a planetary camera. And you see how that moved? I'm almost in the oversampling. I don't know why I keep doing that. I'm almost in the oversampling. So from the 533 to the 585, you can see that move. And that's because my pixel size, the size of the pixels, is smaller. And you can see my resolution went to 0.75 arc second per pixel. So play with this, the scope that you're looking at getting, or the OTA that you're looking at getting, the camera that you're looking at getting. And this is how you know if they match or not. And again, you want to make sure you look up your local seeing conditions because that can matter. Right here, same camera and everything. If I go to poor seeing, then I am oversampling. Choosing a telescope can be stressful. I know I stressed out about it a lot. I did a lot of research on it. Just some advice, don't overthink it. Stick with Cinta optics, whether you go refractor, Newtonian reflector, Schmidt-Cassegrain. Basically, if you stick with Orion, Skywatcher, Celestron, Red Cat, things like that, you can't go wrong. You're going to be happy with the results. You're going to love the photos that you get. Just stick with quality optics and you can't go wrong. Future-proofing yourself is always a good idea. And what I mean by that is if you can afford a mount with a higher payload capacity, go for it. It's never a bad idea to get a mount that can handle more capacity. The more capacity that mount can handle, the better it's going to guide, the better it's going to track. And also, if you start off with a 6-inch Newtonian or a smaller scope, let's just say a smaller scope, you have that room to upgrade your scope without needing to upgrade your mount. Now, one more thing I want to put in there is pay attention to weight. When you are looking at these OTAs, look at the weight, look at the payload capacity of the mount. Just like you have to match your camera to your OTA, you have to match your OTA to your mount. When you're talking astrophotography, you don't want to go over 50 or 60% of the payload capacity. You're not going to get as good at tracking, your guiding's going to be harder, your image isn't going to be as high of quality as it could be. Remember, when you're imaging, you need to stack, and you're stacking many photos on top of each other. So if you have a lot of photos that aren't good, a lot of subframes that aren't good, they're not going to stack correctly. You're going to have issues in that part. You're going to have issues with calibrating. You're going to have issues with the overall processing, and your final image isn't going to be what you expect. So get a mount that can handle what you're trying to put on it. Keep in mind, every ounce counts. So add up your accessories, your autofocuser, your guider, everything needs to get added up, and you need to make sure you don't go over 50 or 60% of the payload capacity. One thing I love about the Skywatcher EQ6R Pro behind me, it is rated for 44 pounds. I'm roughly 68%. I see it in my guiding, don't get me wrong. If I put my Celestron on that, my guiding is amazing. It still guides very well with this OTA on it. It's just not as good. I see some bouncing in there, but 50-60% is the rule of thumb. Just keep that in mind. And if you're able to afford to future-proof yourself and get a mount with a bigger capacity, I would recommend it, so that then you have room to grow. Anyway, I hope that was helpful. And as always, please like and subscribe if this was helpful, you liked it. Share it with your friends. If you want me to keep making content like this. If you have any suggestions, please throw them out there. Put them in the comments. Email me. My email's in there. hiddenlightinquiries@gmail.com. Please give me some suggestions. What do you want to learn? What do you want to hear about? Anyway, stay tuned for the next video. We're going to go over software. I'm going to break that up into a few different parts. We're going to go over all of the software in general, kind of like the introduction to equipment, and then we will break those down into individual videos. Till next time, clear skies.